Welcome, and today we're going to be solving a problem that involves two stationary point charges, and this is under the lesson of electric potential or potential, and electric potential energy or potential energy. So let's begin. The problem is two stationary point charges. We've got here positive 3.0 nanocoulomb, so this is negative 9, and positive 2.00 nanocoulombs are separated by a distance of 50 cm. So be mindful, we've got to convert that cm. An electron is released from the rest at a point midway between the two charges. So electron released from rest. Instead of putting rest, let's have a bit of a variable here. V is equal to 0, meaning the speed of velocity. Rest at a point midway between the two charges and moves along the line connecting the two charges. Now, what's the speed of the electron when it's 10 cm from Q1? Okay, we're looking for the speed when E, I put the negative there, when E is 10 cm from Q1. There you go. What is that? This is the thing that we need to discuss. Now, this has to do with your speed. So the strategy here is important to think of equations with speed. And we already discussed Gauss's law. We also had Coulomb's law. We also remembered what it was, like the work energy theorem, like what did it look like, and the equations that tell us that your mechanical energy is conserved. So hopefully one of those equations would be really useful in this case. Let's see this. The speed or the final speed of the electron. Know that your ME, mechanical energy, which is E, okay, initial, is equal to your E final. We also know that E is equal to your kinetic energy plus your potential energy. So this is initial is equal to K plus U final. This is when your mechanical energy is conserved. So again, if you're talking about the initial, you deal with the UI and KI, meaning the initial kinetic and initial potential. Same is true with your final. So if you're dealing with final, make sure that you're talking about or dealing with the final kinetic and final potential. Now, so this is electric potential. It's not MGH anymore. It'll be like 1/4 pi epsilon naught, the one that we had last time, multiplied to Q naught Q1 divided by your R. So let's see that. We know that it's from rest. So if it is from rest, we know that your Ki must be 0. Okay. Ki 0 because it's from rest. Well, what does it mean? K is 1/2 mv squared and v was 0. So your K1 or Ki must be 0. Right, so let's have the UI or the potential, the initial potential. That would be, we just start here, so 0 plus 1/4 pi epsilon naught. We've got here my Q naught, then Q1 divided by your R, plus, this is several point charges, plus your Q naught, Q2 divided by your R is equal to, what's the K? That is 1/2 mv squared. 1/2 mv, the final, squared, plus your U, which is still the same thing here. Right here. 1 over 4 pi epsilon naught. This is same thing Q1 divided by R plus Q2 divided by your R. Okay. Okay, so 0, I'm looking for this V. Look for that V. Maybe we can simplify the left part of our equation. 1 over 4 pi epsilon naught is just 9 to the 9th. And then multiply it, Q naught Q1 divided by your R. What is our Q naught? In this case, this is our Q. Because this is the one being investigated. It's basically, I've got here, for example, this is my Q1, this is my Q2. This is positive 3, positive 2. We're not talking about axis. This is just the charges. And release from V is equal to 0. So release from V is equal to 0. That would be your electron going there. Okay, an electron is a charge. So that would be our Q naught. What is the final velocity when that charge is 10 cm from your Q1? 10 cm from your Q1. So let's continue here. 1 over 4 pi epsilon naught is just 9 to the 9th multiplied to Q naught. Our Q naught is just an electron, so that's negative 1.6 times 10 raised to negative 19. Don't forget to multiply Q1, which is 3 times 10 raised to negative 9. I know. And you are. This was the diagram. Q1, E, and Q2. Let's have this. 50 cm is 50 times 10 raised to negative 2m. So that would be 1 to 0.5. That's a 0.5 meter. Okay? Now you Q1 and the electron, now Q naught and then Q2. Now, from Q naught to your Q1, it's 25 cm. Trying to have it in m, that's 0.25. 0.250 m. And then plus your Q naught, again, negative 1.6 times 10 raised to negative 9, multiplied to your Q2, which is 2 nano, divided by, from E to Q2, that's 25 cm again, 0.250 m. Okay, that's this and that. Okay, so having the initials first, that would give us negative, without the right side, that is negative 2.88 times 10 raised to negative 17. That's for the first part of the equation. Now, for the second one, we need 1/2 mv squared plus the same thing that we got a while ago. That's basically, I think we can move here. Okay, so negative 2.88 times 10 raised to negative 17. That's the left side already. The next one is the final ones. Okay, so here I have the same thing. Let's just see what's going to be the difference. Negative 19. Oh, there would be difference in radius. Okay, initially that's the case, and then finally that would be 9 times 10 raised to 9. Okay, this is Q naught, Q1, so that's the same. Negative 1.6 times 10 raised to negative 19, multiplied to 3 times 10 raised to negative 9, divided by, this time is quite tricky. So the final one is not 0.25 anymore because your electron would be moving. In this case, it has to do with your Q1. Remember the question, what is the final speed when your electron is only 10 cm from your Q1? So instead of having 0.25, that's just going to be 0.1. 0.1 m. Plus, same thing here. So if the 0.1 m, the other one must be 0.4. So that's negative 1.6, negative 19, multiplied to 2 times 10 negative 9. This is 0.4. There you go. Don't forget the 1/2 mv squared here. And here. 1/2 mv squared. Final. Plus. All right, so retaining our 1/2 mvf squared, we'll get 1/2 mvf squared plus your negative 5.04 times 10 raised to negative 17. Right, there you go. Yeah, joules, of course, J. Okay. We only need to get your 1/2 mv squared. So to get that, we need to have this square root. I think we can remove some of this. Just retain the answers here. Okay. So there we go. All right, so we had negative 2.88 times 10 negative 17 is equal to 1/2 mv squared plus negative 5.04 times 10 raised to negative 17. I can transpose this. I can have negative 2.88 times 10 raised to negative 17 plus my 5.04 times 10 raised to negative 17 equals 1/2 mv squared. 1/2 mv squared. So I need to, after this one, I've got to divide 1/2 m, 1/2 m, be cancelling, and then square root of this because you've got v squared. So your v is actually 6.89 times 10 raised to 6 amperes.